This is Unit 3 Atoms. This is the first video, so we're going to talk about sections 1 and 2 in this video. Section 1 is atoms. What is an atom? An atom is the smallest particle that retains its chemical properties. If you divide an atom further, you would have smaller particles, but they would have completely different properties. An atom is the smallest particle that retains its chemical properties, so we say that an atom is the smallest unit of an element. Let's take a look at the pieces that make up an atom. So there's two generic areas that exist in an atom. There's the nucleus and there is the area outside of the nucleus. The general term for the pieces or the components that make up the atom are subatomic particles. Sub meaning below and atomic meaning the atom. This means below the atomic level. An atom is composed of three unique types of subatomic particles. We have protons, neutrons, and electrons. Each of these three components influences the behavior of the atom in some way. The nucleus. So protons are found in the nucleus and they have a positive charge. You may remember some of these ideas from your 8th grade science classes. A positive charge. Each proton has a charge of +1. Every atom of a given element contains exactly the same number of protons. The number of protons identifies the element. Protons are responsible for the identity of the element. If the number of protons is different, then we have a different element. Neutrons are also found in the nucleus of the atom, and they have a neutral charge. A neutral charge that is neither positive nor negative. The number of neutrons may actually vary from atom to atom within the same element. Although the number of neutrons for one specific atom is not going to change. So if we're looking at a group of atoms, we might have more than one different numbers of neutrons. But if we're looking at one specific atom, it's going to stay the same with its neutrons. Atoms of the same element with different numbers of neutrons are called isotopes. In the current model of the atom, protons and neutrons are held together at the center of the atom in the nucleus. Protons and neutrons account for almost all of the atom's mass. Most of the mass is going to be concentrated in this one small area. Since the nucleus contains only positively charged protons and neutrally charged neutrons, the charge of any nucleus overall will be positive. For now, the nucleus isn't that interesting. It gets a lot more interesting towards the end of the course when we get to nuclear chemistry. The nucleus of any given atom is usually going to stay the same. Not a lot happens until here. Then we have electrons. Electrons have a negative charge. Each electron has a charge of -1. They're going to occupy the area that is outside of the nucleus. The number of electrons in an atom can change. This is how the electrons are a little more interesting. An atom that has an equal number of protons and electrons is a neutral atom. It is not positively charged, it is not negatively charged. It has a lot of pieces that are positive and negative charged, but they are in equal numbers, and so they cancel each other out to make a neutral atom. The electrons orbit the nucleus, and they do it at a very high speed. It's not in neat, nice circular orbits like drawings of atoms might make us think. It's not quite like the solar system. It's this really messy area where the electrons are moving very fast. The area that is surrounding the nucleus has a negative charge. Of these three types of subatomic particles, electrons are probably the most interesting. They're responsible for the chemical behavior of the atom. They are responsible for the chemical bonds that the atom can form. Electrons will determine the type and the strength of chemical bonds that an atom forms. The electrons will also influence the physical properties of a substance. So it will help determine if a substance is going to be flexible. Flexible like metal, you can bend it. Or if it's going to be brittle, like glass or a coffee mug. Something brittle is more likely to just shatter when something happens to it. Electrons determine if it is a good conductor of heat and electricity.